Alrighty, so this is for Quideo chapter 12 through 14 with the basic and advanced question. The drug AZT was the first drug that seemed effective in delaying the onset of AIDS, of which then a study was conducted where it assigned 435 subjects to take 500 milligrams of AZT and another 435 to take a placebo. For part A, we are to give both our null and alternative hypothesis, of which P1 is the subjects given the placebo drug, and P2 is the subjects given AZT. Our null hypothesis is P1 equals P2, and our alternative is P1 is greater than P2. In addition to 4, it is a SRS. The number used is greater than 30. And N is greater than NP, and N is also greater than NQ. Now for part B, we are to determine how significant that AZT is effective, which we will use the equation P1 minus P2 over the square root of P1 times 1 minus P1 over N plus P2 times 1 minus P2 over N. And now what we get from that equation is that we get z equals 2.94, of which then our p-value is 0.9984, which is greater than our alpha value of 0.05. And therefore, it is not sufficient evidence to prove that AZT is effective. And for part C, we are to define a double-blind experiment. And in context, double-blind experiment in the question is when neither the researcher or the patients know what was given to them.
And, well, now for the advanced question. If there is no seasonal effect on human births, we would expect equal numbers of children to be born in each season. A student takes a census of her statistics class and finds that out of the 120 students, 25 were born in winter, 35 in spring, 32 in summer, and 28 in fall. First off, here in part A, we are to outline our null and alternative hypotheses. So our null is that the seasons do not affect the amount of children being born, and our alternative is that the seasons do affect the amount of children being born. For part B, we are to compute the chi-squared statistic, and we are going to use the number of births that are given to us to put into L1, and we have a total of 120, so divide that by 4, our expected value is 30, and put 30 4 times in L2. And now to compute the actual chi-squared stat, in L3 we're going to have L1 minus L2 squared divided by L2, of which then we will have second list, and going to sum, you'll have the calculator add those up, and that will be 1.933. And for part C, we are to find our degrees of freedom, which we have 4 seasons, so 4 minus 1, and that's our degrees of freedom, which is 3. For part D, we have an alpha value of 0.05 and a p-value that was calculated, which is 0.58. In which then we conclude that we fail to reject the hoe that seasons and births are independent of each other.
Created using Powtoon.